So today we're going to talk about this concept of literal equations and dimensional analysis. A literal equation is typically an equation with lots of different variables in it. What we've been dealing with to this point are equations with single variables in it, maybe on both sides, maybe not. But these equations are going to have multiple variables, and you're going to be asked to solve for a single variable in each of those equations. In other words, we're going to isolate that variable. So you can see in our first example that we want you to solve for x. So I need to get rid of everything except the x. And what I usually like to do is I like to get rid of all my multiplications last, if at all possible. So in this case, what I want to do is I want to bring the b over to the other side first. And then if this were a positive number, what I'd do is I'd add the opposite to the other side. So I'm going to add a negative b to both sides. Now there are no like terms, so what we have to do is just say, well, I have ax, or a times x, is equal to c minus b. And then, to undo a multiplication of a, I could either divide by a or multiply by the reciprocal. I'll just divide by a to both sides, and I end up with x equals c minus b all over a. And problem done. We solved the literal equation. So here's a couple more. In this next example, it's very similar to the first. I want to get y by itself. This time we have a fraction. So I'm going to add a negative a, or I could subtract an a to both sides of the equation. Again, no like terms, so I just have b minus a on the right and 3/5 y on the left. I need to get rid of this multiplication of 3/5. The best way to do that is multiply by the reciprocal. So I have 5/3 to both sides. I'll put this all in parentheses. And so my solution, these 5/3 and 3/5 reduce. I have y equals, and I'm just going to leave it like so. 5/3 b minus a. In theory, we could distribute that through, but there's probably no need in this case. The next example, I want to get w by itself. Now, initially I said I want to get rid of all my multiplications first, or last I said. I can distribute this if I want to, and I think I will. And you'll notice what I have. I have 10w minus 5c is equal to 3x. I need to get w by itself, so I'm going to need to move the 5c term over to the other side. Since it's subtracting, I do the opposite of subtraction, which is addition. So I'm going to add 5c to both sides. Again, I have no like terms on my left. 5c plus negative 5c go to 0, so I'm left with 10w. And I have 3x plus 5c. Now I need to get rid of this multiplication of 10, so I can divide by 10 to both sides. And I'm going to do it to the entire term on the left. So what I have is I have 3x plus 5c over 10, and that's my final solution for w. Alright, now this last one's a little bit more difficult. Here's my multiplication. Alright, here's an addition. I want to get w by itself, but I've got this big division of 6 right here. And probably the easiest thing to do on both sides is clear a fraction. So if I multiply both sides by 6, notice what happens. This 6 and this 6 on the bottom reduce, leaving me with 5w x minus 4c. 6 times 7 is just 42. And now it works like a similar problem we've done. I want to isolate the multiplications of the w, so I add 4c to both sides. When I do that, I notice no like terms, so that's 42 plus 4c, and that's equal to 5wx. Now, I have a multiplication of a 5 and an x to the w, so if I want to undo those multiplications, I divide by 5 and x. Both the 5 over 5 is 1, x over x is 1. The right side gets divided by 5x as well. So I get w equals 42 plus 4c over 5x. And I'm done. Alright, that's all we've got with literal equations. Let's move on to dimensional analysis. Now, what dimensional analysis basically is, it's a process of changing to equivalent units by multiplications of different ratios. And here are some known equivalents that we know about in metric and standard US type measurements. So what we're going to do is we'll do the first example, and I'll show you how we go about this. We're going to change 5 yards per second into feet per second. Now, we've talked about unit analysis and unit measures, so on and so forth. The way I'm going to write this is 5, and I put a yard per second. And I'm going to write this another way here. This is 5 yards per 1 second. The one's kind of implied. And what I want to do is I want to change that to feet per second. Well, I already have seconds, which means I need to change yards to seconds. And I have a ratio of equivalence of yards to feet. I know there are 3 feet in 1 yard. Now notice what I'm going to do. I'm going to try to get rid of yards and have feet in my numerator. So we said we have 3 feet per 1 yard. And notice, my units will reduce out, and I'm left with feet and seconds. So I'll have 5 times 3. The yards reduce, gone, gone, and I'm left with over 1, and I have units of feet per second. Alright, which gives me a total of 15 feet per second is equal to 5 yards per second. So that's the dimensional analysis. Now we'll get a little tougher on the next example. So I want 130,000 centimeters per minute into meters per second. So notice I have 2 units to change. I've got to go from centimeters to meters, and then I've got to go from minutes to seconds. And I'm going to do one at a time. So we're going to start out this way. We'll say we have 130,000 centimeters per 1 minute. And let's go from centimeters to meters first. So I know there are 100 centimeters in 1 meter. If I want those units to reduce, there's 100 centimeters, because those will reduce with these centimeters in 1 meter. Notice what this is going to get me. I'll multiply and divide. I have a total of 130,000 meters, because these units are going to reduce out again. Centimeters go, centimeters go. So I have meters per, notice on the bottom now, I have 100 minutes. But in doing this division, these zeros go and these zeros go. So what I really have now is I have 1,300 minutes, or meters, sorry, per 1 minute. Now what I need to do is I need to get to seconds. So I need a seconds on the bottom. So I'm going to multiply by units that are seconds and change minutes to seconds. Notice my minutes units will reduce. So I know that in 1 minute I have 60 seconds. So now you'll notice my minute units will reduce out, and I'll be left with 1,300 meters over 60 seconds. And what I can do now is do the division here. And what we do is we take 1300, divide that by 60, and we want a unit analysis. So what that gets me is it gets me 21, and I know you're going to hate this, repeating sixes, which means 21 and 2/3, that's meters per second. When we do a dimensional analysis, it's probably okay because we want a unit measurement, this many meters in 1 second. So it's okay to have decimals.